Good day once again, students. Today we are going to answer questions. This is our special program to help students, to show students how to answer some difficult and tricky questions in the exams. Answering questions. Today we are going to be taking some questions from chemistry, and the topic is the calculations in chemistry. Calculations in chemistry, when we say the concept of moles, mole concepts. So I'm going to take some questions here. Now the first question here states that for drivers in the UK, the legal limit of concentration of ethanol, molar mass 46 grams per mole. That is the MR, molecular relative molecular mass of ethanol. MR is 46 grams. So that is the legal limit of the concentration of ethanol. This is in the blood is 80 milligram per 100 cm cube. 80 milligram per 100 cm cube. This is equivalent to a concentration of what? They want you to choose the concentration of 80 milligram per 100 cm cube of ethanol. Many of you will make this fundamental mistake, and the answer to that mistake will be in the option. This is one very tricky thing. This is one dangerous thing about multiple choice. That foolish way you are answering it, that wrong way you are answering it, the examiner will also answer it that way and get an answer, and they will with an option to that stupid option will be there in the answer. And my students are not stupid. My students know what to do. So let's go for the wise answer. So you can see, when you are talking about molar mass, ethanol is a compound. So if we are looking for concentration, we say concentration in mole per dm cube. Everything here is a mole per dm cube. You can see is equals to mole, number of mole n, divided by volume in dm cube. Or you can use the normal way you answer it normally, using the 1000. You can use that also. If you are used to that, you can use that. But I am very used to this conversion. So now that's the concentration you are looking for. However, in this, you don't have the number of moles. So first, you have to calculate the number of moles first. This is where the trick comes. N equals to, you are giving mass of ethanol divided by, because it's a compound, MR, which is the relative molecular, or relative, because the molecule there of ethanol. So, but now, all your masses must be in grams. This mass is the milligram. If you put 80 here and put 46, which is the molar mass, you get an answer here. And that answer will be wrong. And you're going to pick that as your option. And that's dangerous for you. So you need to change 80 milligram to gram. 80 milligram to gram will be 80 divided by 1000. This is where the trick is. 1, 2, use your calculator, you are going to get 0.08. 1, 2, 3, 0.08. So that's what you are going to get. So I get n equals to 0.08 divided by 46, because this is now in grams. This is in grams. This is where the trick is. If you don't convert that milligram to gram, you are going to make that fundamental mistake, and you see an option to pick. You come out from the exam, or you say, exam is easy, I got the option. Be careful. So now, before we get the concentration, we need to get this. And as I have calculated earlier on, for it to be fast for us, I got 0.0174. I calculated it earlier on so that to be fast for you, 0.0, how many zero there? 0.00174 mole. 0.00174 moles. This is where another another danger comes. Many students, because you are in a hurry in the exam hall, you get this and you go straight and you get that answer there. That's another problem. You get that and you get the answer there also. If you stop there, you got the first danger. The second danger, you are missing it now. Don't miss that. Don't make that mistake. So divide by this. This is the number of mole. Now you got the number of mole. We don't need this formula again because we already got the number of mole. We got the number of mole to be this. This is the number of mole. We put it there. That's the number of mole equals to divide by volume. Volume we have is what? 100, which is in dm cube. 100 divided by 1000 is what? Is 0.1. Divide by 0.1. And when you divide this, what do you get? You will get the correct answer. You get the correct answer, which is 10. We go here because, and you use your calculator to calculate this, you're going to get 0.0174 mole per dm cube, and that will be your correct answer. I have to check my answer. C, that is the correct answer for you now. Please get the trick. 2 times they tried to trick you. Don't forget that. Let's move to the next question. Which of the following contains the greatest number of hydrogen atoms? Be careful. Be careful. It's another trick. It's another trap for you. Which of the following contains the greatest number of hydrogen atoms? How many hydrogen atoms do you have here? 2. How many hydrogen atoms do you have here in NH3? 3. How many hydrogen atoms do you have in hydrogen molecule? 2. I'm talking about 1 mole first. How many hydrogen atoms do you have in 1 mole of CH4 methane? 4 hydrogen atoms. This is 2 hydrogen atoms in 1 mole of water. But we are talking about 2 moles of water multiplied by 2. This is 3 hydrogen atom in 1 mole of NH3, 1 molecule of NH3. So, but we are not talking about 1 molecule. We are talking about 1.5 mole multiplied by 1.5 moles. Hydrogen gas multiplied by 1. 0.5 moles of methane, we have 4 in 1 methane. 0.5 mole in 1 mole of methane, we have 4. So 0.5, which is multiplied by 0.5. Of course, this is not the number of hydrogen atom we have, these answers. No, the number of hydrogen atom we have, we now have to multiply everything by 6.0 times 10 raised to power 23. 6 multiplied by 6.0 times 10 raised to power 23, multiply by that, and multiply by that. Then the answer we get will be the number of what? The number of atom of hydrogen we have there. So this is the number of hydrogen we have in 1 molecule of each. So multiply, because hydrogen, water, now we are telling you H2O, 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 H2O in 1 mole is this. Then in 2 mole is multiplied by 2. We are telling you the number of NH3. NH3 in 1 mole is NH3, 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 NH3 multiplied by 6 point this. But we are not talking about, so we're talking about how many hydrogen there. So 3 in 1, so multiply by this number will be 2 in 1, multiply by this number, 2 multiply by this. But we're not talking about that, we're talking about 4 now. So having got this, please, I want to re-explain this very well, because they are talking, you can hand it here in this question. I'm deliberately explaining it like this because it may not come like this. The answer may come in form of this. So when you get the answer like this, because they are uniform here, so they cancel out, no problem. But in case it is not given to you like this, it is given to you in form of figure, you have to, because 1 mole of water contains 6.0 times 10 raised to power 23 times 2 hydrogen, because H2O, each H2O contains 2 hydrogen multiplied by this. So, but you have 2 moles, 2 packets of hydrogen now, and each packet contains 2 times this. 2 times this atom, 2 times this number of atom. It's like you have a packet of sugar and you are saying you have in one sugar, you have 2 cubes of sugar. 2 cubes of sugar, that means if you have 2 cubes of sugar in one pack and you have this number of pack, that means you have 2 multiplied by this cube of sugars. But you now have, again, apart, you have 2 of these. So that means you have 4 of the number of cubes of sugar. So this is what you have. Which one will give us the largest answer now? This, let's do away with it because we do not really need it for this question. But in case we need it, that's why in some questions we may need it and we'll come across such questions later. So this will give us 4 multiplied by 10 to the power 6 times 10 to the power 23. This will give us 4.5 multiplied by that. This will give us 2 multiplied by that, and this will give us 3 multiplied by that. Obviously, this one, the ammonia, is giving us 1.5 mole of ammonia is our answer here. Please don't forget that because they have treating atoms. Please, atoms, they said. Don't go for CH4 because it has the highest number of hydrogen. No. Don't forget 0.5 moles of it, not 1 mole. Not 1 mole of it, 0.5 moles of it. So don't forget that. Oh, this is 2, sorry. All right, now let's move on. Oxygen can be prepared by several different reactions. Which of these will give the highest atom economy? Do not forget your formula for atom economy. 2 different formulas you can use, but they're the same for a balanced equation. You say desired MR of desired MR, or relative atomic mass or relative molecular mass of desired product, which is what here? Our desired product here is oxygen. Of course, that's the oxygen here, oxygen here, oxygen here, oxygen here. In this question, we are very lucky. It's half oxygen for everything. Divide by MR of the entire product or MR of the entire reactant. Same. Because the number of atoms you have here is the number of atoms you have here. Same type of atoms. So, divide by number or MR of all product or all reactant. Same. Some students or some books will say, or some teachers will say, multiply by 100%. Some teachers will say all reactants. Some teachers will say all products. So, our desired product is hydrogen. Half hydrogen is 16 grams. So we are half hydrogen is 16 grams, half O2, because O is 16. But O2, which is 1 mole of hydrogen, is 16 multiplied by 2. So, but we have half mole. Half mole will be multiplied by 0.5. So 16 multiplied by 2 is 32, multiplied by 0.5 is 16. So half oxygen is 16 grams. Of course, you all know that at this stage. For these, let's now go. Please write this somewhere because I'm going to clean it. For the first one, I have 16 divided by this Na, which is 23 plus 14 plus 16 multiplied by 3. This one gave me, from my calculation, this one gave me around 16 divided by 85. 16 divided by 85 multiplied by 100%. This one gave me, again 16, everything is 16 there, divide by H2O2 34, because this is 1 times 2 plus 32, so times 100%. This will give me Cl2 plus H2O, which is 35.5 times 2, this is 71 plus 18, this gives me 89. That gives me 89. I can see that here, 89. That gives me 16 divided by 89. Okay, you know better if the teacher is making mistake. And this gives me, your teacher may have a shorter trick, but I'm doing this for the sake of even the students who thinks she's the worst in the class, but she may not be the worst, but she wants to know the reason behind everything. She may be the best in your class, or he may be the best in your class, but he wants to know the reason behind everything. He doesn't want shortcut. So I'm doing this the correct way in case it also comes out in the theory paper. So this, I have 16 again, divide, because this is 16. This is desired product. Divide by, this is 207 lead. 207 plus 30. This one can never be the answer because the denominator is too much. The plus 32. This is 239. 239 times 100%. When you look at everything, it's 16, 16, 16. Which one has the lowest denominator? Which one has the lowest denominator? Of course, this is the one closest to 16. This is the one closest to 16. If it's 16 over 16, it will be 100%. From your mathematics, mathematically, this is the largest. This will give us the largest. You don't even need to calculate. This one will be smaller than this. This one will be smaller than this. This will be the smallest of them all because the denominator is very large. So this is our answer. This will give us the highest percentage. If you calculate it, you don't even need to calculate to choose that. So, but please don't forget, it is telling us, don't forget that it is half O2, half O2. Whatever you have seen my video on atom economy, you know that whatever you have in front, you have to multiply it by 8. Please, from the chemical equation. If you have not seen my video on atom economy, please go back and watch my video on atom economy, and that video also contains other units of what? Other units of concentration. It has 2 topics inside. Let's go. Now we move to the fourth one. Which of the following processes has the highest atom economy? Has the highest atom economy? One thing I told you in my video about atom economy is, I told you, if you want to get the highest atom economy, choose a pathway, choose an equation, choose a chemical reaction that will give you only the desired product. If you get only the desired product, that means you are getting 100% atom economy. That will give you only the desired product, one product. The product you are looking for, only that one. You don't have to do much of problem here. Which of these gives us only one? If it's not giving us only one, that means we have some work to do. But I have done this and I've seen one of them giving you one, only one. Let's look at making polyethylene from ethene. Let's look at making ethene from ecosane. Ecosane means, see, some of you did not do ecosane, but if you look at my video on organic chemistry from your IGCSE or GCSE, I stretched it a little to C20. Your syllabus says to C5, but I made it so interesting that you did not even know when you study from C1 to C20, which is ecosane. So ecosane, of course, they'll put the formula for you there because they will not cheat you in any way. So ecosane, making ethene from ecosane. If you are making polyethylene from ethene, don't forget that we were polyethylene is this. Don't forget that polymerization reaction. Don't forget that polymerization reaction is giving you only one product. If I have 10 of these, it will give me these 10 of it to join together. So I am not losing anything. I'm not losing any atom. There are 2 atoms of carbon here. There are 2 atoms of carbon here. 4 atoms of hydrogen. 4 atoms of hydrogen. 2 atoms of carbon multiplied by 10 is 20. 2 atoms of carbon multiplied by 10 is 20. 4 atoms of hydrogen multiplied by 10 is 40. 4 atoms of hydrogen multiplied by 10 is 40. So I have the same number of atoms I have here. I have 40 carbons, 20 carbons and 40 hydrogen. 40 hydrogen and 20 carbon on this side. If I make it 10, just for example, you put N here in the exam. So, and I make this one, and I make this one, it has to be 10 also because it's polymerization, addition polymerization. So this will also be 40 hydrogen and 20 carbon. Same mass I got here is the same mass I got here. That means if I use my formula, desired product, MR of desired product, this multiplied by this plus this multiplied by, divide by MR of the reactants, or of the product again, I will get 100%. This tentatively, I'm choosing it as my answer. Sometimes you have to look very well because you may be making a mistake. Look at other answer. Don't just see and go. That's multiple choice for you. Making ethene, because some answers are just the first one and they look so nice. You have to check the others. It may be a trick. Making ethene from icosane. This is, you are making ethene from icosane. Icosane is alkane, a long chain alkane, which is petroleum. That means you are doing what? You are cracking petroleum. C20 H42, if you want to get C2H4 from it, you are surely cracking. And that will not be the only product you get from it. Yes, we get a lot of it, but you may also get hydrogen from it. You may also get other alkanes from it. And I told you in my video, you may do this one today, you get this, you get different products. And this tomorrow, you get another product. This is giving you ethene now. If you are getting, imagine you are getting ethene from here, so that means other products will be there. Even if you are getting 8 molecules of ethane, other product must be there. Even if you are getting 10 molecules of ethene, other product must also be there. So that means 2 products are formed. It is not only your desired product you are forming. It is not only, this one we are forming only polyethylene, this one ethene. So that can be an answer. So making chlorine from chloromethane, making chloromethane from chlorine, making chloromethane from methane. Chloromethane from methane, all of you know this from your GCSE or IGCSE. CH4 in sunlight, UV light, you see, it will give you CH3Cl plus HCl. So it is not chloromethane alone you are getting. You are not only getting the chloromethane. It's not only chloromethane you are getting another product. So your atom economy can never be 100%. Some have been used for that. Some atoms have been used for that. Now making magnesium chloride from magnesium and hydrochloric acid. Of course, this is also a simple one from your GCSE or IGCSE. Acid reacting with what? With magnesium, with metal to give you. Of course, we are making magnesium chloride, which is a salt, magnesium chlorides, of course, hydrogen gas. So before we even start balancing or whatever, we are seeing now that we are making magnesium chloride. It is not only magnesium chloride that is formed here, another product is formed, which shows that that atom economy cannot be 100%. So this one, if it was not, you did not get anyone that is up to 100%, that is up to 100%, that means you have to calculate for each of them. So that would take time. That would take time. Examiners, they know this. So that's why you can see one of them that is directly 100%. And I can remember in my video when I was teaching this, I used this as an example. In my video when I was teaching atom economy, I used this particular one as an example, and it's coming out in an exam. So that stands to be our answer. All these ones are wrong. So number 5, the human body contains around 0.25 gram of iodine molecules, I2. Which of the following shows the number of iodine atom? Look at the trick now. You are giving iodine molecule here, I2, but they are asking you of iodine atom. And when I was teaching you in the video which talks about mole, the first formula of mole I gave you, mole and mass of substance, I told you number of mole when it comes to atoms, because some elements occur as atom, monoatomic atom, just one atom, like all the metals, none of them is diatomic, but some elements occur as diatomic, some even polyatomic, like sulfur, S8. So you don't just say that N equals to M divided by MR. No. Now, since we are talking about atom, N divide mass divided by MA, atomic mass, relative atomic mass, not relative molecular mass this time, or relative molecular mass or relative formula mass. No. This time around, it's relative atomic mass because we are looking for atoms of iodine. Don't forget that, please. It's in that video when I was talking about mole, the beginning video of mole. So now they are looking for this. We are looking for number of atoms. If we are looking for number of atoms, we have to use N equals to number of atoms divided by Avogadro's number, which is 6.02, depending on what you are giving, either 6.0 or 6.02, times 10 raised to the power 23. So this is what we use. But for us to use this, we first have to get the number of mole from this amount, 0.025 grams, because we are not giving 1 mole of iodine. If we are giving 1 mole of iodine, we just say this. Then we go. But we are not giving 1 mole of iodine. We are giving something that is less than 1 mole of iodine. So the first thing we will do is to come here and calculate this. So N equals to mass 0.025. I've also solved this for you, so make this our journey faster. Divide by Ma. What is the atomic mass of iodine? Just go directly to your what? To your periodic table and check it is what? It is 126, if I am not wrong, 0.9. 126.9 is the answer. 126.9. 126.9, because it's atomic mass. If it was not atom, if they just say iodine, you have to, because iodine is I2. Iodine does not occur as I, it occurs as I2. If they didn't say atom, you have to calculate it as this multiplied by 2. If they say just iodine or iodine molecule, you have to multiply this by 2 so that you get 253.8. But that's not what they are asking you for. They are asking you for iodine atom, because you want to calculate the number of atoms here. The N here has to be with respect to atoms. Don't forget that. So do I leave this one there because my answers are like that? So let me leave it there like that. Don't let me solve it. So that N I got here, which is this, I transfer it to this place. I transfer that N to this place. I transfer that N to this place. Which is 0.025 divided by 126.9 equals to number of atoms divided by, if I want to divide by 6.02 times 10 raised to the power 23. Of course, number of atoms will be, I just cross multiply, and when I cross multiply, which answer will I get? I get this first answer to get the number of atoms. Please, you can see where the trick is now. The trick lies in the fact that many students will use this as I2 molecule. Please don't forget, from my video, I taught you that if it is of atom, this is what you will use. If it is of molecule, or if it's diatomic molecule, or it's not a metal, it's not one monoatomic molecule, you have to use, if it's diatomic, you have to use Mr. If it is molecule, you have to use Mr. If it's something like ionic compound, you have to use Mr. Please don't forget that. But for atom, because we are looking for that of atom now, that is a trick here. Many students will choose this and they will fail it. So that's our answer. And let's go to number 6. I'm really sorry I'm slow, but I need to explain to you and bring you back to my video on this topic. The Avogadro's constant is this. Therefore, the number of atoms in 1 mole of carbon dioxide is this. You should be able to know this now. In 1 mole of carbon dioxide, it's like I have packs of carbon dioxide, CO2, 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 CO2 inside this box. I have pack of sugar with 3 atoms, with 3 cubes. There are 3 atoms here, 1 carbon and 2 oxygen. 1 carbon and 2 oxygen right in there. 1 carbon and 2 oxygen, carbon, oxygen, oxygen. This is what I have for 1 carbon dioxide molecule. But I have in this In 1 mole, they're asking of 1 mole. 1 mole of carbon dioxide will be this multiplied by 6.02. Okay, now they're using 6.0 times 10 raised to the power 23. So I have this number. It's like I have a pack of sugar, and each pack of sugar has 3 cubes. But I have this number of packet of sugar, this number of molecule of carbon dioxide. How many cubes of sugar will I have? This multiplied by 3. As simple as ABC, isn't it? Of course, yes. I'm looking for the number of cubes inside the pack of sugar, and I have this number of sugar. I have this number of carbon dioxide, the number of atoms. That is the trick. 1, 2, 3. So for me, I'll multiply this by 3. So my answer will be 3 atoms in 1 molecule, and 1 mole has 6.0 times 10 raised to the power 23 molecules. So if I have this molecule and each molecule has 3 atoms, this will be my answer, and 3 multiplied by this will give me this answer here. Many students will choose these because they will not look at just the number of atoms in 1 molecule, 1 mole of carbon dioxide. What the students will see is, despite the examiner is using this one, they are writing here with what? Bold. They wrote it with bold letters. Please, you can see, before you answer this question, before you come to this class, print the question, the PDF document, which is on the website for this, and you follow suit so that you have the question with you. So 1 mole of carbon dioxide has that, and that will be our answer. Now let's go. How many molecules are present in 16 grams of oxygen? How molecules are present in, when you're talking about molecules now, it will now be how many molecules are present in this gram of oxygen. This gram of oxygen, we know this gram of oxygen, we will know N is equals to number of molecule, which is O2 now. O2 divided by Avogadro's number, this time 6.0 times 10 raised to the power 23. You have to look at what you are giving. Maybe 6.02, maybe 6.0. So now, if I'm looking for number of molecule and I need N, so I can use 16 grams to find my N. So I need N is equals to mass divided by, because we are talking about molecule, not atoms here. So I will not use MA, I use MR. MR, which means this is equals to 16 divided by 32, which is equals to 0.5 moles. 0.5 moles. If they just told me number of atom of oxygen gas, I will be using MA here, and MA of oxygen is 16. 16 over 16 to be 1 mole. But they are not asking me that of oxygen atom. They mean O2. They just say oxygen. That means it's molecule. If they just say O2, that means it's molecule. If they say molecule, then it's molecule. But if they say atom, it has to be just single one. Even if it is sulfur that is S8, polyatomic, it has to be, if it's the atom, it has to be 1 atom of sulfur. Okay, so let's continue. So you now put the answer here, bring that answer to this side, 0.5 multiplied by, because this one will now be 0.5 will now be here, multiplied by this, and 0.5 multiplied by this will now get 3 times 10 raised to the power 23 molecules. That the number of molecule will be this, which is D. Our answer here is D. You can see, but many students will make this mistake. They will make this mistake. Please don't make the mistake. All right, let's go. Now, number 8. I have 20 questions to answer here. I have 60 in all, so I have 3 videos for you for this topic. Which of the following statement is true? Avogadro's constant is the number of... Remember, I defined Avogadro's constant for you. Avogadro's constant, remember the definition when I was teaching you moles in the video for moles, in the definition of moles. Please be careful. When you are defining, when you are talking about that, it has to be atoms, number of atoms, or number of molecules, or number of ions, because these are the units of all substances. All substances. It either comes when you break it down to ions, or to atoms, or to molecules, or to ions. So which one do they want us to know now? So we are going to be looking at it. A gram of element which contains this atom of that element. Is that right? The number of gram which contains these atom of the element. Think very well. If they say atoms of the element, if it is sodium, it will be correct. If it is magnesium, it will be correct. If it is helium, it will be correct. What if it is chlorine? Chlorine does not occur as monoatomic. It occurs as Cl2. Hydrogen occurs as H2. Oxygen occurs as O2. So you can say that atoms of oxygen that will be in 1 mole, a constant, that a gram of any element which contains this. No, because it will be, for oxygen to be 2 times this. For chlorine to be 2 times this. For hydrogen to be 2 times this. For sulfur to be 8 times this. So that will be wrong. So because they have mentioned atoms there, that will be wrong, because all elements do not occur as atom. All elements do not, they put elements here and they put atoms here. All elements do not, atoms of elements. So atoms of element, all elements do not occur as atom. Okay? If they say units of element, that will be correct. It may be atom, it may be molecule. So, atom contained in 1 mole of any element. In 1 mole of any element. They're saying the same thing here. It's wrong, because in 1 mole of every element, Cl2 is going to be how many atoms? 2 atoms already. So it will be 2 multiplied by that 6.02 times 10 to the power 23 of Cl, because you have Cl2, 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 which is this time of it. So if you say atom in 1 mole of element, it will be wrong for chlorine, it will be wrong for hydrogen, because they are diatomic. They are diatomic. So if you say in one, say number of, it's units, chemical units contained in 1 mole of any element, you'll be correct, because every element comes as either a molecule or an atom. So you'll be correct. So this is also a wrong one. Atom containing 1 mole of monoatomic element. Fantastic. Monoatomic elements. Sodium is monoatomic element. A mole of sodium is 6.02 times 10 to the power 23. That's Avogadro's number, correct? Magnesium is monoatomic. Helium is monoatomic. Argon is monoatomic. For all monoatomic elements, any element that has 1 atom as its unit, the number of atoms that will be in 1 mole will be Avogadro's number. For now, this is correct. Let's continue. For now, this is correct because they measure monoatomic element, monoatomic elements that have only 1 atom as a unit, not a molecule. Now, particles. This is another tricky one. Students will see this because we say, oh, there's atom, molecule, or ions here. They'll see, oh, atom, molecule, and ion is here. So it's the correct answer. You have to be very careful. Particles, atom, molecule, or ion required to make 1 gram. 1 gram. Come on. A mole of sodium is 23 grams. A mole of sodium is 23 grams. So you can't say particles, this, or this required to make 1 gram. No, 1 gram is not correct. No. So a number of particles, atoms, molecule, or ion required to make 1 mole of a substance. So this is wrong also because they say 1 gram. We can't say 1 gram if Avogadro's number cannot make 1 gram. No. Even hydrogen cannot even make 1 gram of hydrogen because hydrogen is H2. So this is also wrong. So please don't be deceived. Let's go to the next question, number 9. The compound butane. Butane, C4H10. Butane is an alkane, the 4th alkane in the group, in the homologous series. Now you remember this from your GCSE or IGCSE. The compound butane has empirical formula of what? You are talking about empirical formula of this, empirical formula, molecular formula. Everything you have here is empirical formula, molecular formula. First, this is the molecular formula. That is nothing, because remember, we have molecular formula, we have empirical formula, we have molecular formula, we have displayed formula, and we have structural formula. We have, for every organic compound, we have the empirical formula, we have the molecular formula, we have the structural formula, and we have the displayed formula. Don't forget that we treated that in our GCSE or IGCSE. And when we get to organic chemistry in AS, we are going to repeat it again. We are going to repeat it again. All the things we did that will be useful for you for IG will also be in your AS videos. You will not, for those of you who were not with me in your IGCSE, when you come to AS, we always put things you need to know from IG before the AS topic. Remember that. For those of you who have been, ask your brothers who were here before on this platform. Now, this C4, this is the what? This is the molecular formula. Molecular formula. Do we see that anywhere here? We see it here as empirical formula. That already makes this one wrong, because it's not the empirical formula, it's the molecular formula. We see it here as molecular formula. Okay, we are suspecting this may be right. We see it here. We don't even see it here at all. This is general molecular formula, CnH2n plus 2. It's general molecular formula of alkanes. That is wrong, completely wrong. So we see is here empirical formula as this. No, this is general molecular formula. And molecular formula, the molecular formula is correct, but this one has killed this one. So this one killed this one. This one is murdered. This one is murdered, and this one was murdered before, because they are calling the molecular formula the empirical formula. So the molecular formula. So this is the molecular formula. What is our empirical formula now? You have the simplest formula. What can we do? What can we do to this and this to bring it to the simplest? Divide by 2. We now have C2H5. Can we further divide it? No, because this one will give us a fraction or a decimal, which we don't want. This is the empirical formula, empirical, and this is the molecular formula, molecular formula. So our option 2B is correct. The empirical formula is C2H5 and molecular formula is C4H10. So that is B is our correct option. Let's go to the next question. Lithium reacts with water to produce hydrogen. Of course, lithium will react with water to produce hydrogen. We all know that. Lithium reacts, all group 1 metals, when they react with, when you drop them in water, you have to be very careful. Some of them are very, very vigorous. Of course, the least vigorous there is lithium. So it will give us this reaction. Lithium hydroxide and hydrogen. In this experiment, 0.06 mole, which is grams, which is 0.01 mole of lithium, is producing 90 cm cube. Our yield now from our experiment is 90 cm cube of hydrogen at room temperature and pressure. What is the percentage yield of hydrogen? The percentage yield of hydrogen. This is our experimental yield. Let's leave it there. Percentage yield, we know it has a formula. Percentage yield, from the percentage yield video you remember, is equals to theoretical or calculated yield will be down. Calculated yield or theoretical yield. Calculated or theoretical yield here. Experimental yield will be here, or what you get from experiment will be here. Multiply by 100%, because there is no way, no matter how good you are as a scientist, I've told you this in the video, that will be easy for you now. For those of you who have watched the video on this, no matter how good you may be, you can never get perfect experiment, a perfect experiment. No way. Only God can get a perfect experiment. You cannot get it. Now, from our experiment, we got 90. We already know we got 90 cm cube from our experiment. What are we going to get from our calculated? Calculator will be easy, because we know before we started the experiment at all, we were given this mole of lithium, and we know the ratio here is 1 to half. We're only interested in lithium and hydrogen, so it's 1 to half. Whatever mole we get for lithium, which is 0.01, so we are going to get 0.005 of hydrogen, because it's half of it we will get there. We divide this by 2 and we get this. So How do we then calculate the calculated yield? Calculated yield, we're looking for the number of mole of what? From our calculation. So we know this is the number of mole, but this has to be in grams. Experimental yield, we got it in gram already. They have helped us here. We don't need to convert it. So now 0.05 is what we have here. We are looking for the number of this one. It may be in gram, it may be in depending on what you are talking about, it may be in volume, depending on what you are talking about. Now we want to get the number of the amount of volume we will calculate. This is the amount of volume from the experiment. What is the volume we actually expecting? Some people will say expected yield, real and expected. So we have 0.005. Now at room temperature and pressure, N equals to volume divided by 24 dm cube divided by 24 dm cube. So we got our N is 0.005. Is 0.005. 0.0. Let me use another color so you don't get confused. 0.005 equals to volume, which we are looking for, divided by 24. Our volume then will be 24 multiplied by 0.005. 24 multiplied by 0.005 will be what? 24 multiplied by 0.005 will be, I need my calculator here now. I didn't calculate that. 24 multiplied by 0.005. My answer is 0.12. Is 0.12. 0.12. That's 0.12. 24. Okay. Multiply by this. We said 1 to 0.5. If this one is 0.01 mole that we are giving, we're expecting 0.005 moles of this. So that's 0.005 mole. What volume are we expecting from there? 24 multiplied by this, which will be equals to 0.12 dm cube. 0.12 dm cube. That is our expected yield. 0.1 dm cube is in dm cube. Don't forget this is in cm cube. That's another mistake student. So then we start looking the exam hall. How come this one? How come this calculated yield is small? It's so small. How come I have 90 here? Don't forget this is cm cube and this is dm cube. This makes times 1120 cm cube. 0.12 dm cube is 120 cm cube. Don't forget that, please. Open your eyes. So we now have here 90 divided by 120. So 90 divided by 120, of course, times 100 is 75%. Nobody needs to tell us that. 90 divided by 120 multiplied by 100 is 90 there, which is what we're expecting, which is what we got. This is what we're expecting from that calculation, because we have 0.01 of these. We're expecting to get this, but we didn't get it. So what is that we're expecting to get? We calculated it to be this in cm cube. Let's move on. Please, this video is a little bit long. Just bear with me. It is worth it to finish just 20 out of the 60 so that our video can be 3. So which of the following? This is the B part of this. They are now talking about why we are getting lower yield. Now, which of the following is not a possible reason for the yield being less than 100%? A possible reason. I have given you all the reason in the video why the yield will be less than 100. Why the percentage yield will be less than 100%. You know these from the videos. Let's look at it from if we are going to get any of them. Some oil remain on the surface of the lithium. Don't forget that lithium is a group 1 metal. It's highly reactive. You cannot just keep it in any bottle. You have to keep it under oil in the bottle where you have oil, or grease, or inside oil, so that that's why when you bring it out, you need to quickly transfer it into what you are reacting it with, which is water. But don't forget, oil does not dissolve in water also. So some oil may be on the surface of the lithium and that part of the lithium may not react. So this will reduce your percentage yield. So this is a correct thing, which is a possible reason, which is not a possible reason. So this is a possible reason. So it can be our answer. Hydrogen gas is very soluble in water. This is absurd. This is absurd science. This is a very stupid science. How can hydrogen be soluble in water? Look at it. If hydrogen was soluble in water, look at the equation once again. Look at the equation once again. You have lithium in water, and hydrogen is formed. Everything is in water. This is aqueous. Lithium hydroxide is aqueous. So the hydrogen will not bubble out if it was soluble in water. It will just dissolve and stay there. You won't get hydrogen. You can't touch hydrogen outside. You can't produce hydrogen. You can use this reaction to produce hydrogen. If hydrogen was soluble in water, it will just be formed and be dissolved because this is aqueous. So hydrogen is not soluble in water. It's a common sense thing. If anybody tells you hydrogen is soluble in water here, it is a common sense thing. You say no. Otherwise, this hydrogen will have dissolved in this solution because the solution is a watery solution or aqueous solution. This is not a possible reason for less atomic economy. So it may be our answer. Let's continue. A layer of oxide was present on the surface of the lithium. When you bring the lithium out, of course, we bring it out into here. Air, no matter how fast you may be, some part may be exposed, and air will react with the surface, and it will form lithium oxide. Don't forget that. So it reacts very fast. That's why you kept it there under oil, because you don't want it to form lithium oxide. So if that happens, that means you will not get what you are doing. So this is also a possible reason. Some of the hydrogen gas escape collection. Of course, when you are collecting, no matter how perfect you may be, no matter how tight you may tight fitting your apparatus, the joints of your apparatus may be, some hydrogen gas may escape. That's why some hydrogen gas may escape collection. This is a reason, this is a reason, this is a reason. This is the only one that is not a reason, and it becomes our answer. Let's move on. 1.12 grams of iron react with oxygen to form 160 grams of iron oxide. Relative molecular mass of iron is this and this. This is a simple one, but it can be tricky also. What is the formula of the iron oxide? So we start from an empirical formula. When you're looking for any formula like this, we start from the empirical formula. We say iron and we say oxygen. You know, you don't use the molecular mass of the substance. You use the atomic mass. Don't forget, even if it's a molecule. I told you this, I warned you about this in my empirical formula video. Now, Fe 160 gram, 112 gram of iron reacted, 1.12 grams reacted, and 160 gram of the oxide was formed. So if 160 gram of the oxide was formed, from your IGCSE, you know that if you remove 112 from the oxide, 1.12 from the oxide, you will get the mass of oxygen that reacted. So the mass of oxygen that reacted, we will get it. I don't want us to waste time. I'm in number 11. Let me go there and just get the mass for you. So the mass of oxygen that reacted is 1.6 minus 1.12, 0.48. So we have 0.48 here, 0.48. So we got what we are looking for, grams of oxygen. When we subtract this, because this is the oxide, so when you subtract the amount of iron from the amount of the oxide, we get the mass of oxygen which reacted. Don't forget that. So now we divide this one by 56, and we divide this one by 16, and of course we get this one. Divide by 16, we get 0.03 here, I believe, and this one we get 0.02 here. So now divide by 0.02, the smallest one, the smaller one among them, 0.02. I get 1.5 here, and I get 1 here. I get 1 and 1.5 from your empirical formula. Of course, you cannot just approximate this one to 2 like that. It's too small. If it was 1.99 something now, you can approximate it. If it was 1.89 something now, you can approximate, but it's too small. And it is too low for you to call it 1. If it was 1.0 something, you can call it 1. So it's 1.5. So what do? Make it a whole number. The next whole number, we can make it multiply it by 2, which is equal to 3. Whatever you do to it, you do to this. Multiply by 2, which is equal to 2. So we have Fe 2O3. All these we already did in the video for empirical formula in a much slower manner. This is a simple one from IGCSE. Now, oxygen gas can be converted to ozone by passing through electric discharge, and all these are stories. In an experiment, a volume of 300 cm, don't forget it's ratio 3:2. If we have a volume of 300 oxygen, cm cube of oxygen, and they are telling us in the experiments only 10% of it reacted. Only 10% of it was converted into ozone. If only 10% of it reacted, that means 10% of 300 is 30. If I have 30 cm cube reacting here, That means it will give me 20 cm cube here. We have looked at this type of video before also when we're talking about volumes, when we're talking about, so equal volume of all gases at the same condition of temperature and pressure will give you what? You know that Avogadro's law. Same temperature and pressure. Same temperature and pressure. Don't forget that. So 30 cm cube will give you 20 cm cube of ozone. So now what are they looking for? They say total volume of gas present at the end of the experiment. This is a tricky one also. Don't forget, what did you make? You made 20 cm cube. Many students will go here and say, okay, I made 20 cm cube, blah 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 blah. I have. Be careful. You made 20 cm cube. You had 300. Out of the 300, how many reacted? 30 reacted. What did you have left of oxygen? You had 270 cm cube of oxygen left unreacted. 30 cm cube finished, reacted. So that is gone. That is gone. What do you now have at the end of the experiment? What you formed and what remained. So which is 270 plus 20, which is 290, which is C. So what you formed and what remained unreacted. Total volume of gas. Total volume of gas. They did not say total volume of unreacted gas. They said total volume of gas. They did not say total volume of the gas form. They said total volume of gas. A compound as the composition of, this is another simple one, 62.1% carbon. So I have carbon, hydrogen, and oxygen. 27.6, 10.3, and 62.1. All of them must add up to be 100. All percent. So divide by 12, divide by 1, and divide by 16. And after that, when I divided this one by 12, I'm in number 13. Sorry, I'm faster than the checking of the answer. Now, when I did this, I got 5.18. 5.18. If you do it, cross check. Teacher make mistake with the calculator sometimes because it may be in DEG and I may be working in, or in RAD that I'll be working. So 10.3, of course, this is 10.3, and this is 1.73. Sorry, 1.73. 1.73 is the smallest. 1.73. 1.73. You will see the trick now. They cannot just give you directly like this from IGCS. It's so easy. Oh, it's so easy. We gave you direct. That's a bonus one. So 3, 6, 1. 3, 6, 1, which is C, 3, H, 6, O. You don't need to put 1. C3, H6O. C3, H6O. This is our answer. This is our answer. Let's go to question number 14 quickly. Calculate the total number of ions. This is another thing. Don't forget that when we are talking about Avogadro's number, we will also talk about atom, molecule, or ion. These are units of substances. Don't forget that from the video of moles. Don't forget that from the video of mole. The total number of ion in this one has how many ion? One mole has calcium 2 plus, if you dissolve this in water, plus OH. 1 minus, how many of it? 2. OH minus, OH minus. This is what you get in water. This is what you get in water by 1 molecule. But how many molecules do? So you have 3 ions in 1 molecule. 3 ions in 1 molecule of calcium hydroxide. Calcium hydroxide in 1 molecule. So they said calculate the number of ions in 7.1 gram. So that means in 7.13, you have 3 ions in 1. Sorry. So you have in 1, you have 3 ions. So in 7.41 grams, 7.41, let's look number of mole that is, and it's molecule, number of molecule in 1. Oh, sorry, it's not a molecule, just in number of this unit is equals to MR, which is 7.41, divided by 74.1, which is 0.1 mole. 0.1 mole. So if we have 0.1 mole and we say we are looking for the number of molecules. 0.1 mole is what we are after. Don't forget, 0.1 mole is what we are after. Instead of 1 mole times 3 ions, we say 0.1 mole of that times 3 ions multiplied by Avogadro's number, 6.02, because if it is 1 mole, we say 1 mole times 3 ions times this. So that means 3 ions times this, which will be 18 times 10 to the power that. But it's not 1 mole, it's 0.1 mole, so we have to use that. Instead of it to start using formula, there's no point. So we just multiply like this, 0.1 mole multiplied by 3 ions multiplied by 6 times 10 to the power 23. This is easy enough. This is easy enough because if it is 1 mole, it will just be 3 times this. If it is half mole, it will be half times this. If it is quarter mole, it will be 0.25 times this. If it is 1/10 mole, it's 0.1 times this, and it is 1/10 mole. So 0.1 times this, we have what? We have now this times this, 0.3 times 6 times 10 raised to the power 23. So that means we have 1.8 times 10 raised to the power 23. That is our answer, and it is C, 1.8. Are we correct for number 14? Yes, we are correct for number 14C. Now, let's go to number 15. We'll go to number 15. We'll soon finish. We'll soon end it. Please just calm down. Just calm down. I'm sure you are enjoying it. I'm sure you are enjoying it. Maybe boring, but just come on. Let's go. Now, 15 says, mass of magnesium ion is in 1 kilogram of seawater is 1.3. Is 1.3. That's the mass of magnesium ion in 1 kilogram of seawater as 1.3 grams. The concentration in part per million. The concentration in part per million is what? What is the concentration in part per million? Let me just check my mic. Okay, everything is okay. So concentration in part per million, you remember concentration in part per million is mass of the component you are talking about, of components in that water, divided by mass of the whole solution. Maybe it's a reverse, I told you before, of solution. If you watch that video, you will know what I'm talking about. It's a very interesting video, part per million, when I was talking about other units of concentration. The same video as atom economy times 100%. So you will see. So now we have one thing in this thing. We are talking at magnesium ion in seawater. We have 1.3 grams of it. In 1 kilogram of seawater, we have 1.3 grams. Divided by 1 kilogram of seawater has to be converted to what also? Grams. Don't make that mistake. It may be a catch against you. So we say 1,000 grams. Okay? Multiply by part per million. You see, the teacher was making a mistake. Multiply by 1 million. ppm, part per million, multiplied by 1 million ppm. Remember this. So we now multiply this by 1 million. So ppm. So to make the unit look a little bigger so that we don't have to write too much of 0.0000. So this 3 goes here and 30 goes here. We now have 1.3 multiplied by 10 raised to power 3 will be our answer. That is B. That's question number 15, and I hope we got that to be 15. Okay, question number 3 is B. So that is how to solve this. So that you have to change this one to gram also. Please don't forget that. Don't forget that the component we're talking about is this. Change it to this one to gram also. Now we go to the next one. Magnesium oxide reacts with dilute hydrochloric acid according to the following. This is a straightforward one. So check the equation is already balanced. So now we have ratio. We're only concerned with hydrochloric acid and magnesium oxide. Look at it. Look at your question very well. You have the question with you in PDF. So we have ratio 1:2. If I get the number of mole, we're looking for the number of mole of magnesium oxide. If I get the number of mole of HCl, of course I already got this because half of it is this. So I use my formula, which is, I like using concentration multiplied by volume in dm cube equals to N. You can use your 1000 thing if you like. So this is equals to my concentration of HCl is 0.5 multiplied by, and the volume is 20, which is 0.02 0, 1, 2, 3. So which is equals to, I have 1. So this multiplied by 0.02 is then 1, 2, 3, 1, 2, 3. So I have 1, 2, 3. 0.01 mole of HCl. 0.01 mole of HCl. Do you know where the catch is? Some students will just rush because they are in a hurry and pick C. Then you miss it without doing what you are supposed to do. Don't forget it's ratio 1 to 2. So it is half of this, which is 0.005. When you divide that one by 2, mole of MgO. So which is this? B is our answer, which is number 16 is B. Are we right? Yes, we are quite right there. So let's go to question number 17. We have just 2 more. We have just 2 more and it will all be over. Now, a compound was found to contain 2.8 grams of nitrogen. 2.8 grams. We are going for the what? Empirical formula. And oxygen is 8 grams. So this divided by 16, this divided by 14, and when we divide this one by 14, we get what? We get 0.05, and we divide this one, we get 0.02, and this one 0.05. That's what we will get if you divide it. So this divided by the smallest, 0.02. 0.02. This I get 2.5 and this I get 1. Of course, I cannot say N is 1 and O is 2.5. I have to change this one to a whole number because I cannot just approximate it to 3 because it's too far away from 3. So I have multiplied this by 2 to give me 5 and multiply this by 2 to give me 2. So I have N2O5. This is a direct one from IGCSE, which is very easy. D is our answer for question number 17. Are we correct? D is our answer for question number 17. We have just 2 more, as I told you. Which of these solutions does not contain the same number of ions as the other? This one takes a little time because I need to explain to you. Please. First, sodium chloride contains 3 ions. 1 sodium and 2 ions. 1 sodium and 1 chloride, 2 ions. Okay? If it is 1 mole of it, it is times 10 raised to power times 6 times 10 raised to power 23. So 20 sodium chloride also here 2 ions. Magnesium chlorides, MgCl2, so 3 ions, 2 Cl minus and 1 magnesium, 3 ions. And the same thing here, 3 ions. Now you can see they say which one does not contain the same number of ions. There's no way we can get an answer like this. If there was 1 mole, we're talking about 1 mole, then we just multiply all of them by 6.0 times 10 raised to power 23. But we'll still get the same answer like this. So everything, 2 of them are equal, 2 of them are equal. We can't get our answer like that. That's not where we are going because they didn't tell us 1 mole. So we have to look at the number of moles. What is the number of mole here? If you calculate it, if you multiply this one, N equals to C multiplied by volume in dm cube, or you use your 1000 thing, you are going to get this one to be 0.01 mole. So this will be multiplied by 0.01 mole, which is equal to 0.02 mole. Sorry, 0.02 multiplied by 10 times 10 raised to power 6 times 10 raised to power 23, Avogadro's number of ion. This one, if I do the same thing here and I multiply 0.05 by 0.002, and I will get 0.01 also, which is equals to times 0.01 also, same thing, I will get 0.02 multiplied by 6 points, the Avogadro's number. So here, if I do this magnesium has this. If I do this, I am going to get 0.003 mole because I get 0.01 also When you look at it, 20, 0.05, the same thing here, I get 0.01. So this one gives me 0.03. The answer is showing. A very, very intelligent student will just, okay, that's the answer because I have 2 here and this here. This will surely be equal to that. Let's see. So when I do this 1.33 and this, I am getting something at the end of the day. When I multiply it out, I get my final answer to be 0.00 0.0995, which is the same thing as 0.02 as my final answer. So when I multiply this one by the answer I got when I did this, 13.3 and 0.05, if I use this formula, I get an answer. When I multiply it by 3, I got 0.019995, like that, which is the same thing, approximately this. These and these are the same. This is the only one that's odd one out, and that's what they are looking for, which does not contain the same total number of ions. Don't forget, all these things are multiplied by 6.0 times 10 raised to power 23 because it's number of ions they are looking for. So we got the ion in one molecule, we got the number of mole, so we got this and multiply by the Avogadro's number. This time around we are not using because it's just general. They are looking for the odd man out, and that's the odd man out. The last question now, students. Now sodium nitrate decomposes on heating to give this. What is the maximum volume of oxygen? We need oxygen now at RTP, which could be obtained from 0.5 mole. Okay, we know mole ratio is 2:1. If this is 0.5 mole, this has to be 0.25 mole. Of course, we know that. So now they are looking for volume, and I know the number of mole, and they are saying at room temperature and pressure, not standard temperature and pressure. Room temperature and pressure, I told you in my video, is 24. Some countries, they still use the STP. So now I will now get N equals to, because we're talking about volume of gas divided by 24 at RTP. So 0.25 is equals to V divided by 24, and V equals to 0.25 times 24, and my answer is 6. My answer is 6. That is the correct answer for question number 19. Let me check that. That's correct answer for question number 19, and that is the end of this. This is the end of this. The video has been quite long, but you bear with me. I still have more for this topic. This will expose more tricks to you. Should you have any problem, do not hesitate. You know the right thing to do. Send in your video or your question by sending in an email to me, and I will reply you with a custom made video just for you within 24 hours. That's the normal thing we do on this website. So students, good day and God bless.